Okay, so a bit then on connected particles. It assumed that connecting strings are light and inextensible. We've chatted about those two terms before. Light means it's weightless, there's no mass. And inextensible means it doesn't stretch in any way. By Newton's third law of tension acting on the two connected particles will be equal and opposite as shown below. If this is a car and this is a caravan, so the car is maybe pulling this way, and you feel the tension coming out of the car, that direction there, that's the same as the towing force of the caravan then that's pulling that direction there. So we can have those two things. It's important that they're equal, and that'll help us work that out then if required. Example 1, a car of mass 1,000 kilograms tows a caravan of mass 750 kilograms along a horizontal road. The engine of the car exerts a forward force of 2.5 kilonewtons. Resistance and motion of the car and the caravan are alpha times their mass, where alpha is a constant. Given that the car accelerates at 1 meters per second squared, find the tension in the tow bar. A couple of different ways of doing this one. We're going to take each of them separately and try and work it out then from there. So I normally draw my diagram a little bit like this, nothing too fancy, but I do make the tow bar very long so we can fit all my forces in. And we have that. We're going to have it going this way here, double arrow then for my acceleration, and then this must be the car if it's traveling this way here. So the car is 1,000 kilograms and the trailer caravan is 750 kilograms. So what forces do we have? As we chatted then, we have a tension coming out that way, and that's the same as the tension going that way. The forward force of the car is 2,500, remember the 2.5 kilonewtons, and then the resistance. So what do we have? We have resistance for the car, which is alpha times the mass, so that's alpha times 1,000, and then the resistance to the caravan is 750 alpha. So I'm going to take the two of these separately, do F equals ma for them both, and then see if I can solve the two equations simultaneously. I'll hopefully see how this works. There's a wee trick generally for this, but it'll hopefully be okay. So first of all, looking at the caravan, and I'm going to be using F equals ma. Right hand side, first of all, the mass is 750 times 1, we can deal with that. The left hand side, so what forces are acting on this? What's making it accelerate that way? The only thing bringing that forward is the T, that's what's towing it. So that's T, and then take away 750 alpha. Car, again we're using F equals ma. Right hand side is 1,000 times by 1. Left hand side, we have this draw a wee line down here so don't get them confused. 2,500, take away T, take away 1,000 alpha. Can we tidy these up very slightly? We can. So T minus 750 alpha is 750. I'm going to call this equation 1. 2,500, take away T, take away 1,000 alpha equals 1,000. I'm going to call this equation 2, and I am going to add the two equations. I think will be my best option. So I'm going to do 1 plus 2. Sorry, you can just about see this here. Let's move this one. If I do 1 plus 2, the t's should disappear. So let's see, what do I have here? That t is a t. If I add this and this, they disappear. Hope this isn't too complicated for people. And then minus 750 alpha and minus 1,000 alpha is minus 1750 alpha, and then 2,500. So I'm going to have 2,500 minus 50 alpha. On the right hand side I have 1,750. So I'm going to take this over to here and then this over to here. So that means 175 alpha equals 750. Alpha is 750 over 1750. And I hope you know your 250 times tables. That gives me then 3 sevenths. If you put it in your calculator, you get a decimal, but 3/7 is a much nicer answer to deal with because that's our exact answer. We now need then to work out our tension, because that's what it's asked for. So we're going to sub it into 1. We're going to have T minus 750 alpha is 750. T minus, sorry, T, yeah, we'll go for T equals 750 plus 750 upon 3/7. You see that, where that's come from? So I've taken this over the other side and subbed in then my 3/7. And if you do your calculations for the guy, you get 10. So close. 1071 and 3/7 units. A couple of different methods of doing it. You can take it all as one big lump and the t's cancel out. We'll do a few examples like that in class. But generally I do F equals MA for this, F equals MA for this, and then add or subtract the two equations, and that normally eliminates one of the unknowns to work out what we need. Okay.